if you want to go ahead and go into Amplify, we're going to be on 2.4. Okay, so go ahead, go into Amplify. Should be on the warm-up. Okay. So this says that your teacher is projecting pie charts that show data about patient 23 during weeks 5 and 7 of the case study. So remember on Monday, we talked about this patient and we looked at data of from this patient from weeks 1 and 3. And then we also saw it on week 5. All right. So using the gut bacteria key, determine which new type of bacteria has been introduced to patient 23's gut microbiome, and then answer the questions below. All right, so it's going to ask you which new type of bacteria was introduced, and then it's going to ask you what effect do you think this new bacteria will have on patient 23's overall health. All right, so I'm going to go into our modules and I'm going to project those pie charts from week 5 and week 7. All right, so here are the pie charts from week 5 and week 7. So what you're going to do is you're going to find out what this new bacteria is called, and then you're going to answer that second question as well. That second question is asking you what effect do you think this new bacteria will have on patient 23's overall health. Okay, I'm going to give us about 2.5 minutes to do this. Got a little over a minute. All right, you got a little over a minute left. So make sure you're figuring out what this red piece is here on week 7.
What is it called? I can't even read it.
It is called C. difficile.
Okay.
You don't see it?
No, my eyes are bad. Can't read it.
All right, about 30 more seconds to get that warm-up done. So if you were looking at it correctly, Drew couldn't see it, so I just had to tell him what the bacteria was called. And so that is called C. difficile. All right, so in week 7, the patient was feeling sick, and there was a new type of bacteria in his gut that was not there before. So it was a harmful type of bacteria called C. difficile. And why can we assume that it is harmful? Hint, hint, the doctor's notes. Why can we assume that it's harmful?
Because he felt fine before it came, and then now that it's here, he doesn't feel good.
Yeah. Krisha said in the chat, it gives him diarrhea, bloating, and stomach pain. Good. So in the doctor's notes, it said in week 5 that he was feeling well again because of that antibiotic. And so in week 7, he reports some stomach pains, right? So let's go back to our question 2. This is what we're going to try to answer by the end of today. How can fecal transplants cure patients infected with harmful bacteria? So let's go into Amplify. You can go ahead, go into tab 2. All right. Go ahead, go into tab 2. We're going to be looking at mice and their gut microbiomes, okay? We're going to be looking at mice and their gut microbiomes. So before we do that, we learned a little bit about antibiotics on Monday. And we've got a key concept here for you to write down in your interactive notebook. And so antibiotics reduce the number of helpful and harmful bacteria in the gut microbiome. All right, so we noticed from week 5, with all of that space, all that white space in that chart, that he has a lot of empty space because of that antibiotic. And so antibiotics reduce the number of helpful and harmful bacteria in the microbiome. So go up to your interactive notebook. It should be on page 11. Right, so page 11 in your interactive notebook, you're going to write down that first key concept. So it says here that there's 2 today. We're going to come back to this. All right, so your first key concept is going to go right there. Right. When you get done writing that key concept in, let me know in the chat and just type done. So antibiotics reduce the number of helpful and harmful bacteria in the microbiome. Okay, once you're done with that, you can go into Amplify and start looking at the charts that we're going to look at as a class. So once you get these key concepts done, you can go back into Amplify and start looking at that chart. We're going to talk about it for a little bit. So I've got a few people that have got that key concept down. Make sure you're writing this key concept in your interactive notebook. Drew, can you find your interactive notebook? You good? All right, so I'm seeing Abby, Shelby, Addison, Augusty, Kaylee, Risha. Ethan's got his done. Ava's got hers done. All right. So if you need to reference back to this, this is in our module for today. Now, we're going to investigate this question today. How can having fewer than normal bacteria in the gut microbiome affect the overall health of the body? So how can having fewer than normal bacteria in the gut microbiome affect the overall health of the body? Okay, we're going to look at some mice. So an experiment with mice can help us learn more about the microbiome and an organism's health. So first, we're going to compare a healthy gut microbiome of a mouse and a human. So I don't know if you guys have heard this or not. I know this, but did you guys know, or do you guys know how similar mice and humans' microbiomes are, or how different they are? Have you guys ever heard
It's
about?
very similar.
Okay. Drew says they're pretty similar. Have you guys ever heard of scientists doing experiments with mice?
Like how smart they are, or what do you mean? Just like any.
Well, they do experiments with like putting them through mazes, right? I've heard of that. I don't know if you've heard of that. Shelby sent me a message and said, I know they need to, but I think it's mean to the mice. All right, so we're going to look at the human and a mouse, gut microbiome. All right, so I'm going to go into Amplify. Let's look and see or talk about some similarities and some differences in a human's microbiome and a mouse's microbiome. Okay, so you can either unmute yourself or you can put it in the chat. What do you see between these two? What are some differences? What are some similarities?
They have a lot of the same bacteria in the same portions.
Yeah, they have a lot of the same bacteria and the same portions of that bacteria. Okay, Shelby sent me a message and said one has more B. fragilis than the other. So B. fragilis is this dark blue, not the darkest blue, but the second darkest blue. Okay, Addison points out something pretty good. So mice don't have actinobacteria. I don't even know how to say that, guys. They don't have that certain type of bacteria, so that light purple. One has B. animalis and one doesn't. Yep, so that's that light purple, the one I was just trying to announce. Okay, so that's the biggest difference that I see, is mice don't have this light purple bacteria. So other than that, they're pretty similar, right? They have about the same portions, like Kaylee said, of each of these bacteria. All right. So now we're going to look at the results of an experiment with mice. So we're going to look for some patterns in the data that may help us identify causes and effects of having fewer bacteria in the gut microbiome. All right, so we looked at, I'm going to go back to our warm-up. We looked at week 5 and them not having a lot of space in here. What did we say could possibly happen if they don't have if they do have a lot of space and all of this is not filled up with bacteria? Okay, Krisha said more bad bacteria can enter. Right? So when they don't have this much space, more bad bacteria can enter. Addison said they're more likely to get sick. Those are really good points. I went a little too far. Okay, so we're going to look for some patterns in the data that may help us identify causes and effects of having fewer bacteria in the gut microbiome. So scientists wondered whether a low bacteria gut microbiome, so one that has a lot of space, so a low bacteria gut microbiome, they wanted to know whether it made mice more vulnerable to what's called a salmonella infection. All right, have you guys ever heard of salmonella? Anybody ever heard of salmonella?
Yeah, when you eat raw stuff, you get salmonella.
Yeah, so have your parents ever told you or made sure that they cook their chicken long enough? My parents are always
Don't,
like, make sure that's cooked all the way through.
don't eat the raw cookie dough.
That's what I told my last class. I absolutely love eating raw cookie dough. I don't know about you guys, but I love raw cookie dough. It's like the best.
There's a no baked bakery, and me and my mom got baked cookie dough by there, and it was very good and tasted real.
Yeah, but that's not, I think that's like, it's not cooked, but it's not like real cookie dough that you would
Safe
bake.
to eat.
Yeah. And Shelby said her mom is scared of runny eggs. So if you guys have heard about eating eggs raw, some people do, and it kind of grosses me out. I know they do it for protein, but eating raw eggs probably not the best idea.
No, you gotta leave them a bit runny with toast. You get big and strong.
Yeah, I don't like it when it's like over hard. That's what you call an egg if you cook it too long. So at this, I forgot to tell you, they were doing an experiment on 40 lab mice. Okay, so 40 lab mice. Now, in one of the experiments, the mice had a healthy gut microbiome. So over here at the top left, they had a normal, healthy gut microbiome with 20 mice. Okay, so they did this with 20 mice. And then the other 20 mice had a low bacteria gut microbiome. Right? So let's look at some test results. They both were ingested with the same amount of salmonella bacteria. Okay, they were both ingested with the same exact amount. Now, the test results are what are different with both of these. There were 5 mice that were unaffected and that remained healthy for the normal gut microbiome. 12 of those got sick from the salmonella, slightly sick, and then 3 of those got really sick from the salmonella infection. Now, take a look at the test results for the low bacteria gut microbiome. All 20 of them got really sick from the salmonella infection. All 20. Okay, so in Amplify, I'm going to let you go in and do some annotations. Okay, I'm going to let you go in and do some annotations. We're going to watch this video first on how to do those annotations, okay? So I'm going to share my computer sound. We're going to watch this video real quick.
Let's look at how to observe data and record your observations. The chart on the left shows that the mice with normal guts have full gut microbiomes made up of 5 different types of bacteria. The chart on the right shows that the low bacteria mice have almost the same groups of bacteria, but they have significantly fewer bacteria in their guts. The low bacteria mice have more space in their gut microbiomes because only a small portion is taken up by bacteria and other microorganisms. You can use the plus symbol to leave a note that summarizes this observation. More space. You can also record questions you have about the data. For example, is Salmonella a common type of bacteria? In this experiment, all of the mice ingested the same amount of Salmonella bacteria. Out of the 20 mice that had a normal gut microbiome, only 3 got really sick from Salmonella infection. That's much lower than the number of low bacteria mice. Let's record the observation that fewer of these mice got sick. Active reading skills like these can help you make and record observations about data. Let's look at how.
All right, so we're going to do some annotations and amplify. So you guys can go ahead and you are in tab 2. You're just going to click next down here. So you'll see this first little circle at the bottom. You're going to go to that second circle. So that second circle is going to take you to a place where you can annotate what is happening here. And so what that person just said is you can click this plus sign. It will add an annotation and then you can drag it wherever you want to. Okay, so all you need to add is at least 2 annotations. Okay, so 2 annotations, and I'm going to set a timer for about 2 minutes because we've already seen this and we've already kind of talked about it. I want you to put 2 annotations on this page. Okay. About 30 seconds left. So we kind of already talked about those pie charts. So we're going to move on to activity 3. So we're going to read about the Salmonella bacteria. So we kind of know a little bit about Salmonella, right? We've said something about it's in raw eggs, it's in cookie dough. If we don't cook our chicken enough, Salmonella could be in that. So we're going to read just one section of this article together. Okay, we're going to read it together. So I'm going to read, and so as I read, I want you to think about some of these 2 questions. So how does Salmonella bacteria in the gut microbiome affect the body? And why were the low bacteria mice in the experiment more likely to get the Salmonella bacteria infection? All right. Think about those 2 questions. How do Salmonella bacteria in the gut microbiome affect the body? And why were the low bacteria mice in the experiment more likely to get the Salmonella bacterial infection? Okay, so you guys can go and amplify and follow along. I'm going to read the section that we are supposed to read. Okay. So it starts with the environment. So if you're here, you can follow along with me. It's in tab 3. So Salmonella lives in the guts of all kinds of animals, especially birds and reptiles, and usually gets passed around through animal waste. Whether a person gets sick from ingesting certain kinds of Salmonella can depend on the amount of food and space available in his or her gut microbiome. If the gut is home to lots of beneficial bacteria, the Salmonella bacteria can't get enough food and space to reproduce. On the other hand, if there's not many beneficial bacteria in the gut, the Salmonella population can grow and take over, causing illness, which in this case is more commonly known as food poisoning. Salmonella can be killed using heat, so cooking food properly is one way to keep from becoming sick. Last little paragraph. When lots of helpful bacteria, shown here in the green on the left, are present in the gut, there is little space and food available to harmful bacteria like Salmonella. This helps prevent the harmful bacteria from infecting the gut. When there are fewer helpful bacteria in the gut, there is more space and food available for harmful bacteria that can cause disease. Okay. Now, let's look at those two questions. How do Salmonella bacteria in the gut microbiome affect the body, and why were the low bacteria mice in the experiment more likely to get the Salmonella bacterial infection? All right, let's start with question 1. So how do Salmonella bacteria in the gut microbiome affect the body?
It's like a stomach virus. They start throwing up and having diarrhea.
Okay. Have you all ever had food poisoning before?
It's the same thing.
Salmonella is not always the reason for food poisoning, but Salmonella will cause some food poisoning. Right? So why were the low bacteria mice in the experiment more likely to get the Salmonella bacterial infection? Let's answer that one. Second question.
Because they don't have as much good bacteria as probably the other ones do. Because the salmonella, it needs a lot of room to reproduce, and so with less bacteria, it has more room.
Good. I really like your answer, Drew. Shelby messaged me and she said that they have more empty space. So we talked a little bit about patient 23 having more empty space. Krisha said they have a lot of open space in their body for other bacteria to enter. Perfect. So the more space they have to enter, the worse they're going to be, right? The less bacteria they have to fight off this bad bacteria. Now, we've got a key concept. This is our second key concept that I'm going to have you all put in your interactive notebook. Abby said that they are more likely to get sick. That's a good point if they don't have that good bacteria to fight off the bad bacteria. Right, so this key concept is going to go into your interactive notebook. So it says living things with fewer than normal helpful bacteria in their guts can become infected more easily because there is more food and space available for harmful bacteria. This came straight from the article, guys. Straight from the article. And so get this copied down in your interactive notebook, and then let me know when you have that done. Okay, once you get done putting this key concept in, you can go ahead and go back into Amplify on tab 4. It's going to say applying new understanding to patient 23. Yes, you can hand in tab 3. So if you have not yet, make sure you hand in your annotations from tab 3. So whenever you're in doubt when it asks you to hand in something, make sure you always press that hand in. If you don't, I will not see it. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got about 10 people that say they have this key concept done. Make sure that you have this in your notebook. Now, after that, we're kind of going to go back to our warm-up and why we're going to answer the investigation question. And we're going to back it up with some evidence. So our investigation question, let's go back to it. It was here, perfect. How can having fewer than normal bacteria in the gut microbiome affect the overall health of the body? How can having fewer than normal bacteria in the gut microbiome affect the overall health of the body? Go back. All right, so this key concept that we just wrote down is going to be our claim. So when we talked about scientific argumentation on Monday, we said that scientific argumentation starts with what? What does scientific argumentation always start with? Ava, do you remember what scientific argumentation starts with? Jocelyn, do you remember? Keely, do you know? Remember what scientific argumentation starts with?
No.
Okay, this is going to be on your weekly check-in that I'm going to publish here after we get done with this lesson. All right, scientific argumentation is always going to start with a question. It is always going to start with a question. So see right here down in the bottom left, a scientific argument begins with a question. It has a claim that proposes an answer to the question. It has evidence that supports the claim, and it clearly explains how the evidence supports the claim, which is reasoning. Okay. So our question, our investigation question, this is the answer to, well, this is the claim to that question. So living things with fewer than normal helpful bacteria in their guts can become infected more easily because there is more food and space available for harmful bacteria. Now, what evidence do we have to support this claim? What kind of evidence can we pull? Where can we pull that evidence from?
The reading.
Correct. We can pull it from the reading. We can use pictures. We can use any statements in the reading, correct? Or we can use, Shelby just pointed out to me that we can use the charts. So activity 4, since mice and humans have similar gut microbiomes, we can use what we learned from the mice experiment today to help explain what might be happening to this patient 23. All right, so these are the normal gut microbiomes. We're going to look back at data from patient 23 during week 5. So what do we remember happened in week 5? What do we remember happening during week 5? Or
The
leading up to
patient
week.
feeling better.
Okay, because of what?
Antibiotics.
Antibiotics. Okay. Now, we've talked a ton about this blank space, and we've come to the conclusion that having all this blank space is not good, right? We want this whole thing filled up, not with bad bacteria, right? We want this thing filled up with good bacteria. Now, look at data from patient 23 during week 7. We saw this in the warm-up. We see that their doctor's notes said that they are not feeling good at all. And so they have the C. difficile bacteria, right? So if they didn't have all this space, if all of this was filled up, what do you think might happen if this C. difficile bacteria tried to get in here? If this was all filled up instead of there being space? Okay, Krisha said it would have a hard time entering the body. So if we are looking at this right here, so this normal human microbiome, and we're looking at this right here, it's going to have a harder time, that C. difficile bacteria is going to have a harder time getting into that normal human gut microbiome than it is to this one right here during week 5. Okay? So that's what tab 4 kind of goes over. Okay, so we use some evidence from the charts. We use some evidence, like Drew said, from the article. We can use pictures, right? So you guys do not have to hand anything in. We were kind of just talking about what happened from week 5 to week 7 and why that happened. So if you go on to the next activity, that next activity is going to be your homework. There's an article here. I think it's 1, 2, 3, 4, 5 paragraphs that you're going to read. There's a lot of pictures on here, so make sure you're paying attention to a lot of these pictures. They have a lot of good things and comments to say under them. Okay. So that is going to be your homework tonight. One last thing before class is over. I'm going to go up here into modules. And so each week, you guys, for the past 2 weeks, we had some kind of weekly check-in or chapter check-in. And so that's going to be a reoccurring thing. We are always going to have some type of check-in for the week, unless it's some weird week where we don't have time for a check-in. So I'm going to scroll all the way down here. You guys are going to see week 5. You're going to see what we did on Monday, see what we did on today. You'll see the retakes. And then down here at the bottom, I'm going to publish it right now. And I need you to take that by Friday. So that is our weekly check-in. That will go over kind of what we did on Monday and what we did today. Okay, so that needs to be due. That needs to be turned in by Friday. Okay, so you've got 2 things to do for me. You've got the homework and Amplify, which is you're gonna read about the C. difficile bacteria. So we had already read about Salmonella. The C. difficile bacteria is going to be a little bit different. So if you want to write this down, I want you to do at least 3 annotations in this article. At least 3. If you want to do more, that is totally fine if that helps you out more. But I want you to do at least 3. If you need to write that down, you can. I'll make sure to put it in the announcement I send out after class today. Okay, so at least 3 annotations for your homework. please don't forget to hand that in, because if you don't hand it in, I will not see it. Okay, so homework with annotations, and then weekly check-in. They're both going to be due on Friday. All right. If y'all have any questions, just let me or Miss Straub know. If not, I will see you guys on Friday.